Okay, let me read the question now. Faye buys a block of ice cube. On the journey back home, the ice melts at the rate of 5.5 centimeter cube per minute. Determine the rate of change of the side length in centimeter per second of the ice at the instant when the side length is 15 centimeter. So this is the question part A, which consists of the differentiation concept. So let me read the question for part B now. Okay, given that d over dx in a square bracket 5 over 1 minus x square equals to gx, find the integral of in a bracket 2gx plus 3 close bracket dx. Okay, so for question 4 part A, it consists of differentiation concept, and for question 4 part B, it is consists of the integration concept. Okay, so within this question 4 itself, we actually have 2 chapters in it. Okay, so take your time to solve this question, and we will begin the discussion with the question 4 part A and followed by question 4 part B in a count of 5, 4, 3, 2, 1. Let us begin our discussion for the question 4 part A, where they ask us to determine the rate of change of the side length in centimeter per second of the ice at the instant where the side length is 15 centimeter. Okay, so let us write down the relative information given by the question. Okay, it is given that the ice melts at the rate of 5.5 centimeter cube per minute, guys. Okay, which means that the rate of volume changes throughout the time is 5.5 centimeter cube. But here is the catch, guys. Okay, the ice is actually melting, so the melting process indicates that your volume is actually reducing as the time passes. Okay, it indicates that it should be a negative change, guys. Okay, so from here we can denote that our dv over dt, okay, in this case that dv over dt, it's represent as rate of change of volume with respect to time is equals to negative 5.5 centimeter cube per minute. Okay, but the question asks us to determine the rate of change of the side length in centimeter per second. Okay, so technically the first step what we need to do is we need to convert this centimeter cube per minute into centimeter cube per second. So we need to standardize the unit, guys. Okay, so how to do that? Okay, let me show you the working here. So from here negative 5.5 centimeter cube. Okay, and then you divide with 1 minute. Okay, and then in the bracket times with 60 seconds per 1 minute. Okay, why we need to do this conversion? That so in 1 minute is actually 60 seconds, guys. So from here the minute and minute will cancel off, it only left with the seconds. Okay, so from here negative 5.5 centimeter cube divided with 60 seconds. Okay, so from here you get approximately negative 0.09167 centimeter cube per second. Okay, you can leave your answer in this way, or if you want to leave your answer in fraction form also can. Okay, if you leave your answer in fraction form, it will be negative 11 over 120 centimeter cube per second. Okay, so this is not the final answer, guys. Okay, this is technically the first step. Okay, so I hope you're able to understand the working till now. So now once you already convert the dv over dt in terms of centimeter cube per second, okay, the next step what we need to do is we need to come up with a chain rule formula, guys. Okay, since this concept is involving rate of changes, okay, so in order to solve the rate of changes concept, we need to apply the chain rule formula, guys. Okay, so in this case, how to get the chain rule formula? Okay, read the question carefully, guys. Okay, they tell us that a block of ice cube and the ice melts at the rate of 5.5 centimeter cube per minute. Okay, so they gave us that the volume of cube. So within the volume of cube, we can come up with a formula. So from here, given that volume of cube, okay, V is equals to, okay, length times width times height. So in this case, since it is a cube, all the three sides will have the same unit. So in this case, for example, we denote it as L times with L times with L. So from here, volume of cube V, it will be equals to L to the power of 3, or L cube for instance, guys. Okay, so from here, for the next step, what you're going to do is we're going to differentiate dV with respect to dl. Okay, dV with respect to dl. Okay, so from here, what you're going to do is we're going to differentiate this. Okay, 3, okay, we bring it to the front. Okay, the L, okay, it remains the same. So the power 3 we minus with 1. So from here you get 3L square. Okay, so far so good. So from here, we have already find dV over dt, in this case, which is negative 11 over 120 centimeter cube per second. And we already have dV over dl, which is 3L square. And the question asks us to find the rate of change of the side in centimeter, which in this case is actually dl over dt. Okay, the rate of change of side length in centimeter. Okay, side length means is considered as length, guys. Rate of change of length with respect to time. So this is the one we need to find. Okay, so how are we going to find? So we're going to apply using the chain rule. Okay, so let me write the working over here. So using the chain rule, okay, so from here we are required to find the dl over dt. So let me write the required the expression over here, derivative. So from here, dl over dt, okay, it is equals to, so dl we write it over top over here in the numerator, okay, and we write the multiply symbol over here, okay, and then the dt we write at the second part of the derivative, which is at the denominator. Okay, and these two common derivative we're going to write as dv. Okay, we're going to place as the dv over here, dv and dv. Okay, so that's how we're going to solve this question over here. And by the way, if you look at some of the tutorial videos that I've discussed, so this formula, you'll find it very common, but otherwise please kindly go through some of the differentiation video, guys. It will be very useful for you. So continue to our discussion over here. So from here, dl over dt is equals to, okay, so dl over dv, it's already given that dv over dl is 3l square. So from here, dl over dv is 1 over 3l square. Okay, so from here, times with dv over dt, we already find at the earlier stage of the working, which is negative 11 over 120. So from here, we're going to apply here negative 11 over 120. Okay, so up until now, I hope you guys are clear. But then for the next step, what we're going to do is we're going to substitute L equals to 15 over here, okay, which is actually represented as 15 centimeter. Okay, so the 15 centimeter, what we're going to do is we're going to substitute over here. So from here, when L is equals to 15 centimeter, so from here, dl over dt is equals to 1 over 3 times with 15 square times with negative 11 over 120. Okay, so you solve this. So from here, you should get your answer. dl over dt is equals to negative 11 over 81,000 centimeter per second. So this is your answer for the question 4 part A. So let me underline the solution. So we're done with the discussion for the question 4 part A. So let me proceed for the discussion for the question 4 part B now. Okay, so for the question 4 part B, they ask us that given that d over dx in the bracket 5 over 1 minus x square is equals to gx, find integral of 2gx plus with 3 in a bracket dx. Okay, this is an application of differentiation and integration. So let us solve this together. So from here, integral, okay, let me write the integral over here, 2gx plus with 3 close bracket dx. Okay, so from here equals to, so this 2 we can bring it to the front, and then the integral we can split this into 2, but before that let us do it one by one, guys. Okay, so from here 2 gx dx plus with integral of 3 dx. Okay, we already split the integral into 2, so this 2 we can bring it to the front, 2 integral gx dx plus with integral of 3 dx. Okay, so given that gx is equals to d over dx in a bracket 5 divided 1 minus x square, okay, which is the derivative of 5 divided with 1 minus x square. So let us substitute them over here. So from here 2 in a bracket d over dx, okay, in a bracket 5 in a bracket 1 minus x square close bracket dx plus with integral of 3 dx. Okay, so let's solve this together. So from here, when you have an integral and a differentiation over here, automatically you get the exact expression over here, guys, because integral and differentiation, it will cancel off each other, so you only left with the expression itself. Okay, so from here you should get 2 in a bracket 5 1 minus x square, okay, plus with, so let us do the integral for this, integration. So from here you get is 3x plus with c. Okay, so from here 2 times with 5 divided with 1 minus x square, so from here you get is 10, okay, divide with 1 minus x square plus with 3x plus with c. Okay, so this is your answer for the question 4 part B. Okay, so this question is actually a mixture of differentiation and integration, guys. Okay, so that is all for the discussion for the question 4. I hope you find this video useful. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, please make sure that you subscribe to the channel and hit the bell icon for more upcoming Math tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.